We are now going to start to look at the way we handle quantities for chemical compounds. And the first process here is determining molar mass or molecular weight. So we look at the periodic table, and each element has associated with it a atomic weight. The atomic weight on the periodic table has two units that are available for it. The small unit would be atomic mass units, AMU, or internationally it's abbreviated just U. And this is the mass unit that is appropriate for atoms and ions and molecules. But it's not very useful for us in the lab because we can't weigh AMUs in the lab, at least not with typical equipment. We need some very fancy stuff to weigh that. So the other unit that is appropriate is grams per mole. It's the same number. So oxygen has a mass of 16 AMU. It's also 16 grams per mole. So this is the unit that's appropriate to us because now we can convert between grams, mass, and moles. So we can go to the laboratory scale, weigh out grams, and determine how many moles that we have. And that's what we want to know, is how many moles that we have. Because in our chemical reactions, it's a molar ratio between the different elements. So molar mass I'm using here, I'm representing here as capital M sub m for molar mass. That'll have units of grams per mole. Grams per mole, right there, shows us how we can derive molar mass. That's the equation for molar mass. So molar mass is mass in grams divided by moles. So M is mass, N is moles. So M over N, mass divided by moles, is molar mass. But this, let me see here. Our first step here is to calculate the molar mass of compounds. So all that we're going to do is add up all the atomic masses of all the atoms or elements in the compound. So this just means watching the subscripts and using them to add them up. So if we want to get the molar mass of acetic acid here, we have a total of 4 hydrogens, 2 carbons, and 2 oxygens. So we get the atomic mass of hydrogen multiplied by 4, atomic mass of carbon multiplied by 2, atomic mass of oxygen multiplied by 2, add those up, and that'll give us the molar mass of acetic acid, 60.06. And when we do molar masses of compounds, I like to see 2 decimal places. Not less. More is okay, but I like to see 2 decimal places. So for molecular oxygen, which is how we find oxygen in the air, is O2. So that means we have to multiply our atomic mass by 2 to get the molecular mass. That means the molar mass of molecular oxygen is 32 grams per mole. For water, we have 2 hydrogens, 1 oxygen, so we multiply atomic mass of hydrogen by 2, add on the oxygen, we get 18.02 grams per mole. So there's a couple ways that we can calculate moles. We haven't covered them all yet, but we'll get there. So right here, the middle one is the one we just did. So if we have mass and molar mass, mass divided by molar mass will give us moles. For Avogadro's number, atoms divided by Avogadro's number will give us moles. And then for solutions, solutions is molarity times volume will give us moles. And that'll be coming up shortly. So, if we have moles, what can we calculate from that? Well, we can calculate number of atoms by multiplying moles by Avogadro's number. That'll give us atoms. We can calculate mass. Moles times molar mass will give us mass. Then for solutions, we can calculate molarity by taking moles divided by volume. And in this case, that would be moles of the solute divided by volume will give us molarity. Or we can calculate volume. Moles of solute divided by molarity will give us volume of the solution. So our molar mass, this allows us to convert between mass and moles. So molar mass is our conversion factor between mass and moles, and of course it's unique for every compound. So we have a unique molar mass for every compound. Should have a third equation up here. But molar mass is mass divided by moles. We can rearrange that and get moles is mass divided by molar mass. Or the third form is moles times molar mass will give us mass. So if we have 35 grams of calcium sulfate, how many moles of calcium sulfate are present? So our first step is we need to get the molar mass of calcium sulfate. So we add up the mass of 1 calcium, 1 sulfur, 4 oxygens, and we get the molar mass of calcium sulfate is 136.1 grams per mole. Now that we have the mass of molar mass of calcium sulfate, we can go on to calculate the moles of the compound. So moles of the compound is going to be mass divided by molar mass, so it's 35 grams divided by the 136 grams per mole. We see that the grams cancel off. The mole being in the denominator of the denominator ends up in the numerator, so we end up with 0.257 moles of calcium sulfate. So if we have moles of sodium sulfate, how many grams do we have? So if we have 0.576 moles of sodium sulfate, we want to calculate grams. First step, of course, is to get the molar mass of the compound. So we add up 2 sodiums, 1 sulfur, 4 oxygens, and we get 142.0 grams per mole. So now that we have the molar mass, we're looking for mass, so we just need to multiply our moles by molar mass. So 0.576 moles times 142.0 grams per mole. We see the moles cancel off, leaving us with grams, and we end up with 81.8 grams of sodium sulfate. Sheets. We don't have the sheets yet, but what do we have here? We have iron with a density of 7.86 grams per cubic centimeter, atomic mass of 55.85. We could have pulled that off the periodic table. And we want to know volume. So let's see, what do we have here? Volume of a half a mole. Okay, so we're looking for volume. We're going to get volume from density. But to get volume from density, we need to know mass. So we're going to use the atomic mass to convert moles into mass. So this is combining two things that we know already. So we knew how to work with density. Now we know how to work with molar mass. So we're going to just put them together sequentially to go from moles of iron to volume of iron. There it is. So we're going to go from moles to mass to volume. So to go from moles to mass, we're going to use our atomic mass, which was given to us already. It was given to us in AMU. AMU is equivalent to grams per mole. So the number is the same. We just change the unit from AMU to grams per mole. Now we're going to multiply our moles by the atomic mass. That will give us grams. That will be 27.93 grams of iron. Now we're going to use the density. We have density of 7.86 grams per cubic centimeter. So we're going to take our mass and divide by density. The grams will cancel off, leaving us with cubic centimeters, and we end up with 3.55 cubic centimeters for half a mole of iron.